You were given this handout on the general topic let f be continuous and non-negative on the closed interval a to b. The volume of the solid revolution that's generated by revolving the region R about the y-axis, very, very important, is concentric right circular cylinders. Use cylindrical shells to find generate and the x-axis is revolved about the y-axis. So here the axis of revolution is the y-axis, but because it's a cylindrical shell, I'm going to integrate from x equals 1, and that's the point 1, 1. I didn't label it. And then that's the point 4, 2. Only perpendicular to the x-axis. So the cross sections represent cylindrical shells, and these cross sections are parallel to the axis of revolution. Parallel to the y-axis, the axis of revolution. At each x in the interval 1 to 4, from x equals 1 to 4, the vertical line segment from x those cross sections sweep out cylindrical shells, and the area of any cylindrical shell that you from 0, 0 to the cylindrical shell here, that distance is going to be x. You have times x times x 1/2. Derivative of x to the 3/2 is 2/5 x to the 5/2. It's up to you. I did not at this point, and I simplify and got a single the rest of this informal surface generated by an arbitrary cross-section of the region taken parallel to the axis of revolution. So this time you the point where which are cylindrical shells are parallel to the axis of revolution, but we're integrating with respect to x. On the other hand, if we have a problem where the axis of revolution is the x-axis, we're using the method of cylindrical shell. The cross sections are cylindrical. I believe I have a problem where I can show you what that would look like when the axis of revolution is the x-axis. What I wanted to show you is the problem that I gave. I've got it with respect to x. Collect like terms, and I'm going to add an x squared to each side. And you get x squared is equal to 2. So x is equal to plus and minus the square root of 2. Possibilities there. So x is equal to a negative square root of 2. X is equal to a positive that equals 0 is boundary, and this is the y-axis. You'll see this in the graph. That's when the not x and y, and we're at the y-axis. We're going to go the squares represent 1, so 1 and 2. 1. And I want to work on graphing the two functions, or curves, y equals x, and y equals the square root of 4 minus x squared comes from. It'll come down here. If you have the circle with center 0, 0 and radius 2, minus x squared, and then the whole circle has a radius of 2. So I'm going to make this line dotted for now. cross section parallel to the axis of revolution, and it represents the another boundary. If you wanted to sketch in a dotted vertical line, this is your region. Cross sections are cylindrical shells revolved about the y-axis, so you're going to integrate with respect to x. This is going to be the height of the cylindrical shell, and this distance from 0, 0 to this place on the x-axis is going to represent radius. That's a volume by shape axis or axis. So you're integrating with respect to x. But for this particular problem, you're going to have to say from x to x and the brackets to represent the height of a cylindrical shell. I got to put on top. That's where it changes. Instead of just f of x, because that means just one function's given, two functions are given here, so the manipulation of it is the one on top minus the one on top. Would be x minus x. So all of that in brackets represents the height. And this is radius here. X is equal to r, the radius, and this is equal to h, the height. The cylindrical shell distribute x to the square root of 4 minus x squared, and also to this x. The way top minus bottom or collect like terms, so we go ahead and distribute the x there. And then what I did is I split it to 0 to square root of 2, x times the square root of 4 minus x squared, and then I said minus from 0 to those. This one's going to involve U sub. This one does not involve U sub. You could keep your 2 pi out. I'll say you could so you could do it that way also. So I'm going to leave the 2 pi outside of all of this, and I'm going to do my sub. And du is a negative 2x dx. If x is 0, then u is so that when I come down to this point, I can be in terms of u. So negative 1/2 in place of 0. U is 2. And I did not rearrange, but this is multiplication. So this is going to simplify to the square root of u du. When we go from this definite integral in x to this definite integral in terms of u. For this next one, I'm going to be down as I'm not going to find any antiderivatives. But that one it's okay to have in a problem 2 separate definite integrals where one is u sub. So from 2 to 4, u to the 1/2 power. Because that just bothered me that it went from 4 to 2. It needs to be going from 2 to 4. And to do that, and then again here I'm just going to bring this one over without doing anything. Now I'm ready to apply a x to the 2 plus 1 over 2 plus 1 from 0 to square root of 2. That I'm going to do next. Before I perform the fundamental theorem of calculus, I'm going to simplify my antiderivatives. So it's going to use 1/2 times 2/3 u to the 3/2 from 2 to 4 minus 1/3 x for this one, I'm going to bring out the 2/3. 1/2 times 2/3 is 1/3. Theorem of calculus, 32 quantity q minus q. Okay. And then you just have to continue to simplify for out of the way. 4 to the 3/2 power is like taking the square root of 4 and then cubing it. And then 2 to the 3/2 power here, this is minus so I'll just write that down. Minus 0. The square root of 4 is the same thing. Cubed minus the square root of 2 cubed is going to be the square root of 2 times the square root of 2. So the square root of 2 cubed is the square root of 2 times the square root of 2 times the square root of 2. If you need to see square root of 4, so it simplifies to 2 square roots of 2. And keep bringing it down, 2 pi over 3. Be 8 minus 4 square root of 2. Have a so I'm going to say 2 pi over 3 times 4 times 2 pi over 3 times 2 minus the square root of 2. And remember, the final answer has to be a single quotient. Final is 8 pi in the numerator times the 2 minus the square root of 2 in parentheses, all divided by 3. So that's one way to give it as a single or single closed 8 pi times parentheses 2 minus the square root of 2 divided by the algebra part. Setting of the problem up was not bad once you understand that the height is the curve on the bottom of the cylindrical shell. Now, the last question dealing with cylindrical shells is use cylindrical shells to find the volume of the solid generator when the region enclosed by the given curves is revolved about the x-axis. Give exact answer reduced to simplified. You're going to integrate with respect to y. Square minus equals 0 and x minus 1 times x minus 1 equals 0. So this gives us x minus 1 equals 0. X same thing as the x-axis, but it's also f of x equals 0. So f of 1/2 is going to be 0. Minus 1 is the square root of 1 minus 1, which is the square root of 0, which is 0. So regardless, for this, y is 0. And then for this one, and the axis of revolution is the x-axis for this cylindrical gel. So we have the 0.11. So 1, 2, 3, 4, 5, 6, 7, 8. So the 0.11 is up here. You could try putting in values like 0, get of a -1. So that's non-real. So we're not going to include that. Like that equals there. So the one on top, well, I guess it doesn't matter. I shouldn't say top. So clear. I'm going to put in the square root of 2x minus 1. So there's y equals the square root of 2x minus 1, and there comes in y equals x. And that looks right on the money there, according to what respect solution is the x, and the cylindrical shells are parallel to the axis of revolution, the x-axis. Now we've got to set the problem up. So I'm going to go back to the graph, and I'm going to say that there's the y equals x. It's here's the point, 0.5 negative 1, 0.5 negative 0.5. I would still have my cross sections. Right is the y equals square root of 2x minus 1, and the curve on the left is y minus x. Now, in order to say right minus left, whatever's easier. I'm going to let it be x is equal y equals 1. 2 pi times, and this is where the height is something other than gy So there's the setup for the problem. Back at your picture, we're going from y equals 0 all the way up to y equals 1 with these cylindrical shells. So we're going this way. Y equals 0 to y equals 1. About the x-axis. Now the rest of this is to how the work, you could bring out the 2 pi and have pi plus so 1/2 y cubed plus 1/2 y minus y squared, and you're basically ready to square this other 1/2. This is going to sit, and then this one is going to be minus y cubed over 3, and then take the derivative of 1/4 y squared and you get 1/2 y. Take the derivative of negative 1/3 y cubed, get negative y squared. minus 1/8 0 to the 4th plus 1/4 0 squared minus 8 plus 1/3 LC. So 84 times 3 times 1 is times, and 3 goes into 24 times. 3 plus 6 is 9 over 24 minus 8 over 24. So that's 2 pi times 1 over 24. Pi over 12. So there you go, 2 problems that involve cylindrical shells. Do note that 2 problems that it's not always that complicated. Sometimes with these problems, cylindrical shells, they give one curve, one function, and you basically but when I ask you as in the first problem, the general formula when you're and with respect to y, then the axis of revolution had to be the x-axis, so this would be the general formula. When you integrate with y-axis was the y-axis. Even though on some problems you'll have to do top minus bottom and right minus left. Section that we're going to go over together is arc length, and we'll be covering that in class together. Have a great day and God bless you.